Okay, good morning once again. We will move towards the physical chemistry. Already we have started with the polymer chemistry, and we have seen the general idea in basic terms regarding the polymers. Now, today here we have to talk about the classification of the polymer. Just I am sharing the screen. That we have seen already. Okay. Now in your syllabus, there is a classification given in the different types for based on the origin, based on the structure, based on that particular you can say the physical forces or say molecular forces. Then based on the that particular nature means organic polymer and inorganic polymer is given. There are so many different types of the polymers are there. Here just picture has been shown to you. The natural polymers are there, the synthetic polymers are there, inorganic polymers are here. Inorganics other than the carbon hydrogen, there will be that element present in that particular polymer. And in the organic, the carbon hydrogen and other groups will be there too, but other groups are too. Then synthetic polymer, you are very much familiar with all these particular things. Just we will see the video regarding that, whatever was in the your.
Poly means many and mer means unique or structure.
It is audible.
This is single unit, hence we called it monomers. Monomers are small repeating units combined to form macromolecules, that is polymers. These monomers are combining and forms polymers. A giant macromolecules made by monomers having high molecular mass about 10 raised to 3 to 10 raised to 7 unified. Polymers examples are bakelite, PVC, polyvinyl chloride, low density polyethylene, high density polyethylene, terylene, vulcanized rubber, and neoprene. Now, classification of polymers. Polymers are classified on the basis of their sources, on the basis of chemical structure, on the basis of mode of polymerization, on the basis of molecular forces, on the basis of types of monomers, and on the basis of biodegradability. Now, first type, classification of polymers on the basis of sources or origin. It has three types: natural polymers, synthetic polymers, semi-synthetic polymers. Natural polymers are obtained from the natural sources, that is plants or animals. Thus, it is further divided into two types. First, plant polymers, second, animal polymers. Plant polymers are obtained from plants. Example, cotton and linen. Linen are obtained from the cotton plants and flax plants respectively. Natural rubber is manufactured from the latex which is obtained from rubber trees. Second, animal polymers. Animal polymers are obtained from animal sources. Example, wool is obtained from sheep's hair. Second, silk is obtained from silkworm. Semi-synthetic polymers are man-made polymers, that is artificially prepared by polymerization of one monomer or copolymerization of two or more monomers. Example, nylon, terylene, neoprene. It is further divided into three types: fibers, synthetic rubbers, and plastics. Next, Semi-synthetic polymers. Semi-synthetic polymers are derived from natural polymers, or it is the modification of a natural polymers, also called regenerated fibers. Example: cellulose acetate rayon, cellulose nitrate viscous rayon, cuproammonium rayon are obtained from natural cellulose. These are used in preparation of non-inflammable photographic films, cinema films, varnishes, etc. Second broad type is classification of polymers on the basis of chemical structure. Now, depending on joining of monomers, it is classified into three types: A. Linear or straight chain polymers; B. Branch chain polymers; C. Three-dimensional or cross-linked polymers. The linkage of monomers depends on the nature and number of functional groups present in the monomers. Linear or straight chain polymers. This polymer is made by linear arrangement of monomers. Hence, it is the linear straight chain polymers. Its monomer contain polyethylene. Example: polythene, high density polythene, and polyvinyl chloride. Branch chain polymers. Monomers linked into the form branch. Its monomer contain three functional groups or monomers having side chain. Cross-linked polymers, network polymers, or three-dimensional polymers. This polymer is made by cross-linking of linear polymers. This cross-linking is due to polyfunctional groups present in monomers. Examples are bakelite, melamine, vulcanized rubber. This is the cross-linked polymers. Third type, classification of polymers on the basis of mode of polymerization or polymerization processes. The process in which low molecular mass compounds, that is monomers, combine and form high molecular mass compounds, that is polymers. Low molecular mass compound linked by covalent bond. These are the monomers, and then product is high molecular mass polymer. Now, three modes of processes of polymerization: addition polymerization, also called the chain growth polymerization; condensation polymerization or step growth polymerization; ring opening polymerization. First, A. Addition polymerization or chain growth polymerization. Polymer is formed by addition of monomers without loss of small molecules. Monomers contain double bond. Polymerization, also called the vinyl polymerization, because most monomers related from vinyl group. There is no intermediate is formed in reaction mechanism. It is the free radical mechanism, also called the chain growth chain reaction, which involve three steps: chain initiation, chain propagation, and chain termination. This is the vinyl chloride and vinyl cyanide, also known as acrylonitrile. Now, step first in free radical mechanism, chain initiation. It is initiated by a free radical. Free radical is produced by initiator, which may be catalysts like benzoyl peroxide, acetyl peroxide, tertiary butyl peroxide, etc. Example, acetyl peroxide produces methyl radical. This is the acetyl peroxide. Here, breaking of the bond. This is the homolytic breaking, which form the acetyl radical, and again loss of carbon dioxide form methyl radical. Free radical, alkyl radical or methyl radical attack to olefin, or also known as alkene, or vinyl monomer and produce the new radical. This is the attack and formation of new radical. Step 2, chain propagation. New radical in step 2 further react with another vinyl monomer and form again new radical. The repeating of this step occurs, which is fast, and this step is called chain propagation. New radical attack next vinyl monomer and another new radical is formed. Last step third, chain termination. Chain termination has several methods, but one termination method is by combination of two growing or propagating chain radicals and then formation of polymer. Next type, condensation polymerization. It is formed by combination of two polyfunctional monomers by elimination of small molecules like water, methyl alcohol, hydrochloric acid, ammonia, etc. It is called the condensation polymer. These polymer contain ester linkage. Chain growth occurs by a series of condensation steps, hence it is referred as step growth polymerization. It do not have the same elemental composition in repeating unit and its monomer. Example, formation of terylene, also known as dacron or polyester, from the monomers like ethylene glycol and terephthalic acid. In this reaction, an alcoholic OH hydroxyl group of ethylene glycol condenses with carboxyl group of terephthalic acid by eliminating a water molecule. Now, ethylene glycol react with another monomer terephthalic acid. Here, lone pair of oxygen attack on the electrophilic carbonyl carbon, and then removal of OH group with H group of ethylene glycol form the loss of water, and then terylene dacron or polyester polymer is formed. Next type, ring opening polymerization. Ring opening polymerization proceeds by addition of single monomer to grow the chain molecules. It has same elemental composition of repeating unit and its monomer. It is a strong acid or base catalyzed reaction. Cyclic amide lactam, cyclic ether lactones, etc. are the cyclic compounds. They polymerizes through ring opening polymerization. Example, polymerization of E-caprolactam to nylon 6 polymer formation. Next, polymerization of E-caprolactam to nylon 6 polymer. Here E-caprolactam react at temperature 533 Kelvin to 543 Kelvin in presence of water or nitrogen gas. Then nylon 6 polymer is formed, and right hand side is the repeating unit of nylon 6. Now example, indicate the type of polymerization in the following example. Now first has addition polymerization and second has condensation polymerization. In addition polymerization, there is double bond which shows the addition of methyl radical. And in second example, OH group attack to electrophilic carbonyl carbon and then loss of water molecule. Next type, classification of polymers on the basis of molecular or intramolecular forces. The property of polymers like tensile strength, elasticity, toughness, etc. depends on the intermolecular forces. Hence, polymer is further classified as follow. First, elastomers. These polymers are soft, stretchy, and possess plasticity. When polymer is stressed, then polymer chains stretches, and due to cross-linking, this polymer not tear. When stressed is removed, then polymer regain its original shape. These polymers are used in making rubber bands. Example, neoprene, vulcanized rubber, Buna N and Buna S, etc. Next type is fiber. Solid polymers, solid polymer chains formed a thread-like structure due to hydrogen bonding and strong dipole-dipole interaction is called fibers. This is strong polymers and possess high tensile strength, hence prevent to break nylon. Example, nylon 6,6, nylon 6, kaolin, etc. Third type is thermoplastic polymers. Thermo means heat and plasticity means polymer can be shaped or molded. On heating, this becomes soft, on cooling, becomes hard, hence they can be remolded and recycled. This polymer has properties between elastomers and fibers. Example, polyethylene, polystyrene, polyvinyl like polyvinyl chloride, etc. Next, thermosetting polymers. It is rigid polymers. During formation of this polymer on heating, it becomes soft for giving shape and gets hardened. It becomes infeasible due to excessive cross-linked of covalent bonds. Hence, cannot become soft on further heating. Hence, it cannot be remolded and recycled. Example: bakelite, urea, formaldehyde. Next, classification on the basis of type of monomers. It has two types, homopolymers and copolymers, also known as heteropolymers. In homopolymers, it is formed by joining the single or same monomers. It has one type of repeating unit. Example, polyethylene, propene, nylon 6, polystyrene. In copolymer, it is formed by combining two or more than two different monomers. It has two or more than two types of repeating unit. Example, Buna S, Buna N, kaolin, nylon 6,6. In homopolymers, monomers are same, and in copolymers or heteromers, monomers are different. Next type, classification on the basis of biodegradability. It has two types, biodegradable polymers and non-biodegradable polymers. In biodegradable polymers, the natural fibers polymers are affected by microbes and get destroyed by their own, called biodegradable polymers. Example, PHBV, nylon 2, nylon 6. In non-biodegradable polymers, synthetic polymers are not affected by microbes and remains as a waste material in environment, called non-biodegradable polymers. It created the environmental pollution. Example, nylon 6, nylon 6,6, polyethylene, etc. Now here in environment, biodegradable molecule PHBV and non-biodegradable polymer nylon. As the time passes, after the millionth of year, biodegradable polymer gets destroyed by their own, and non-biodegradable polymer remains in environment as a waste material and creates the environmental pollution.
See here, based on the nature or backbone chain, organic polymer and inorganic polymer. Organic polymer in which whose backbone chain is made up of the carbon chain which is attached to the hydrogen, oxygen, nitrogen, etc. Example, most of the synthetic polymer. And inorganic polymer is nothing but whose backbone chain do not contain carbon atom, glass, silicon, rubber, etc. This is only the left part was there. And here you have seen this particular linear, then the branch and the cross-link polymer. The one left is the cyclic polymer that is in your syllabus. It is amorphous polymer. It is relatively new class of the polymer which is used in packaging, films, lenses, vials, displays, and medical appliances. Okay, that part was left. Otherwise, all the classification is shown in your particular that presentation. Okay. Have you any difficulty regarding this?